For pre-cal, we're going to do your statistic review. For future reference, this is not going to include normal distribution. Sadly, with us having to do online learning, that's just something I didn't expect you to know, or bell curve. However, in a normal school year with ideal settings, we would cover both of those topics. But for now, let's just throw some numbers out here. And let's find some basics. Well, first, sample size. Let's throw one more out there. We'll say 8. Sample size is how many is there. So we've got 7 pieces of data. Sample size is 7. Mode is something else that you don't have to put it in any particular order for. Mode, the number that's there the most. 8. If I had not added that 8, notice how there would have been no mode. Not 0, but literally no mode. And as far as technically for mean or the average, we don't have to put them in order, but I'm going to go ahead and do it. So let's say we've got a 7. Well, let me start down here, because we're going to need to go all the way across in a minute for standard deviation. So we've got a 7, 2 8s, 10, 14, 15, 19. Okay, we got them all. So let's say, I might as well erase, make it pretty. So let's say I wanted range is something we can find fairly easy. So range is highest minus low. So 19 minus 17, 12. Mid-range, you don't use very often, but it is what it sounds like, the middle of the range. So 19 plus 7, 26, divided by 2, 13. But by far the number we use the most, mean, or the average. So let's add them all up. So we've got, let's see, 15, 25, and 8, 33, 29, and 19, 81. Let's see, 9, 29, 6, 7, 23, 33. Okay. Divided by 7. So 11.6 we'll say is the mean. And remember, for symbols, the mean is also x with a bar over it. That's going to come into play in just a second. So then that leads us to where we need to find sum of squares, variance, and standard deviation, followed by z-scores. Remember, your first column is x minus the mean or average. So 7 minus negative 4.6. 8 minus 11.6, negative 3.6. It's the same. Negative 1.6. What is that? 2.4. 3.4. Yep, 7.4. So once you get all those, remember then you're going to square each of them. So you're going to have 4.6 squared plus 3.6 squared plus, of course, 3.6 squared again. Oh, I'm sorry. I move my calculator over. Plus 1.6 squared plus 2.4 squared plus 3.4 squared plus 7.4 squared. Should be all of them. Enter. Oh, wrong column. 121.72. So this, hence it's all of your square column added up, it is your sum of squares, or what I like to do, SS. So that's your sum of squares. Now to find your variance. Your variance is the sum of squares divided by the sample size minus 1. So 121.72. Sample size was 7, so we're going to divide by 6. So 20.3 is our variance. And last but not least, remember this symbol stands for standard deviation. It's the square root of the variance. So square root of 20.3, 4.5. So standard deviation, 4.5. And last but not least, if you want z-scores, remember the median, I'm sorry, not the median. Oh, we didn't find median. Okay, we'll come back and do that. Sorry about that. We'll get to it in a second. It's not the median, it's actually the zero or the z-score of the mean or average is 0 because it is on the average. If you have like a standard deviation of 1 and so forth, and then -1 and so forth, then that gives you, it tells you as far as, in this case, the standard deviation is 4.5. So if you want to find the z-score, how far the particular data is above or below the standard deviation, then all you have to do is divide by it. So the z-scores is going to be x minus x bar over the standard deviation. So 4.6, technically negative. I'll just put that in manually. So that would be 1.02, or we'll just say 1. Then, negative. Then 3.6 divided by 4 point, what did we say? 5. -0.8, that one's the same, -0.8. 1.6 divided by 4.5. Negative, we'll say 0.4. 2.4 divided by 4.5. Positive 0.5. As you can see, it's tedious, but it's not hard. It's just you've never done it before. So 0.4 divided by 1.6. Notice how, of course, the ones that were below the average have negative z-scores. The one above the average have positive z-scores. And the last thing, since we're not getting too deep into it this year because of the coronavirus, the empirical rule. The empirical rule is if the data is mound-shaped, in other words, remember the most famous mound-shaped data is called a bell curve, which sadly we won't get to. But if it's in mound-shaped data, the empirical rule will apply. Within one standard deviation is 68% of the data. Between two standard deviations, 95. 3 standard deviations, 99.7, will be between those particular data. And the only way I would give you something like this is, let's say your average is, or your mean is 90, and your standard deviation is 6. If I were to ask you, what interval would 68% of the data lie? Well, 68% just means one standard deviation. So think of it, 90 is my middle. So one standard deviation is 6 to the left, 6 to the right. If I wanted to know what interval 95% was, well, 95% is 2 standard deviations. So that would be, if my center's 90, 2 of those. So 12, subtract 12, add 12. Now I could even give you, let's say, give you the interval. Let's say 72 to 108, and you tell me what percent of data has to lie in there. Well, you know, from 90 minus 72, that's 18 divided by 6. That's 3 standard deviations. So 99.7%. And sadly, like I said, since we didn't get to normal distribution and bell curve, that's all you would be expected to know from this chapter. Have a great day.